So yeah, let us. So the first question was kind of a geometry question, right? Given this for a specific reason, but let us see. So we had, let's say that there is a rectangle, okay, such that when you put a square in this rectangle, or I should rather say you take out this square part. So see, this is a square part. Okay? So you take the smaller side and you fit the square there. Okay? And then you are left with this remaining rectangle. It's not getting smaller. It's automatically becoming a square. I don't know what. This is rectangle. Okay. So now the question is, if black rectangle, so if black rectangle is similar, okay, similar to the red rectangle, and I will say what similar means if it is needed to be said in this case. Okay, then find the ratio of the sides. Find the let's say that this side is 1, and find this x. Yeah, maybe better to just label this. Find AD. No, not AD. Yeah, fine, that is right. Find AB. Right. So I had asked this question. So has anybody tried this? So not to all, not ask all of you, but has anyone tried this so far? No. Okay. So first, what should similar mean in this case? So everybody knows similarity of triangles, right? So what is similarity of triangles? When we have one triangle and we have another triangle, when do we say it is similar? Anyone just come say the definition?
So when all the angles are equal and the corresponding sides are in the same ratio.
Yes. Okay, so if all the angles are equal, then it will also imply the corresponding sides are in the same ratio. You're correct. But what is similarity trying to really do in some way? Okay, what it is saying? It is saying basically that this one and this one, when you zoom this one, like, when you demagnify this, right? Or when you magnify the smaller one, you get the larger one, right? So the larger one is just the zoomed in version of the smaller one, right? And when you zoom in something, I mean, unless it's some very advanced zooming, I don't know, some other special effects. But if you just zoom in the plane, just stretch the plane uniformly, right? Then all the sides they multiply by the same ratio, right? If you zoom in and then this 1 becomes 2, then let's say if this is 3 by 2, this will become 3, right? And if this is, let's say, 2, then what will this become? It has to become 4, right? So it is just that common sense. It is just that intuition that all of us have, right? When you zoom something like that, it just means that everything just gets scaled. Scaled is the word. So that's all similarity means. And then there are some conditions like all angles are equal, then it's similar. Then some other conditions. There's a good convenience, ways to get similarity. But that's what similarity is trying to do. So now let us try to extrapolate. See, in maths, you have to extrapolate because otherwise, you see, it becomes a big burden, right? If you have to remember definition of similarity of square and then similarity of polygon tomorrow, the day after tomorrow, similarity of cubes, this becomes burdensome. You have to understand what similarity means. Then you can more or less know the definition, more or less. There's still some details may be there, but you don't have to remember so much. Okay, means yeah, unrelated remembering. So, what would similarity of two quadrilaterals mean? If this is one quadrilateral, and let us say that I have another quadrilateral, and so what would it mean to say that these two are similar? Just use your, just imagine and say it could be wrong, right? Actually, there's no wrong, right? It is because it's just a discussion, right? No, nothing like, and it is like a subjective question. I'm not asking you to find something. I'm just asking you to say what do you think similarity means? Similarity of these two shapes means. Yeah.
I guess they are similar when like 3 of the angles are of same degree value, right? In both the quadrilaterals.
Right. So you could say that. Yeah. So you could say that this quadrilateral is similar to this quadrilateral, which is not precise, but yeah, then you could say that I would say that two quadrilaterals are similar if this is angle and this angle is equal, this angle and this angle is equal, and let's say this angle and this angle is equal. Right? And then obviously the fourth angle has to be equal. Okay. So this is Satya's definition of similarity. Anyone else has any other definition? No, everybody wants this definition only. Fine. So I mean, if we have this definition, would we? What would we expect for the sides? Would you expect something for the sides? Let me label everything and then. So we are slightly straying off the original question, but let us do this discussion maybe. Let's see how far we want to go, and then we'll stop it. In the sense, pause it. So let us say that the angles are same as I have marked in the order that I have marked. The angles are same. Then what would you expect for the sides? Would you expect anything like the ratios or something?
Yeah, so like the ratio of any two corresponding sides should be a constant value, right? For all, taking all sides.
Should be. Yes, it should be, but we don't know so far. But then it should be, right? So let us try to see if it is true. Is this side ratio equal to this side ratio? I don't know, I'm asking. Because see, nobody told us that it is true, right? For triangles, it is true because you can prove it, or because let us say that is as a theorem we all know, so fine, that is okay, let's assume that. And it's not hard to prove it. But what about this?
So in the same way, we can divide this quadrilateral into a triangle, right? And prove it that way.
See, if you divide this into then because then but can we say that this angle is equal to this angle?
Oh, yes, we can, right?
How? Because that is not told to us originally. See, for example, we know that this angle B1, C1, D1, this double marked angle, for example, is equal to B2, C2, D2. That is told to us. But we don't know a priori that this B1, C1, A1, I mean this one, this part is equal to this. That is not told to us. Is it true? I don't know.
Oh, but in both diagrams, when we draw the line to create the triangle, it bisects the angle, right?
No, it doesn't bisect. No.
Oh,
Just draw some picture and see. I will. Then it is fine. But if it doesn't bisect, then this is an interesting question, right? So let's think about. Do you think so? Anyone? You think it will be same? So basically, see, the question has boiled down to this: whether this green thing, this green part, is equal to this green part. So the question is B1, C1, because that's all we need to do. If we can show that, then we can come to the triangle. We can use the triangle thing, because then A1, B1, C1 is similar to A2, B2, C2, and then we can use our triangle ratio. And this is a question mark. Because in the triangle geometry, just angles being same implies the side ratio is same. That we all know very good. But in quadrilateral, is it true?
But I don't think only knowing that the angles will be equal, we can say that the quadrilaterals will be similar.
Right. Okay. Yeah, that is what we are also, yes. Why? What is your explanation? What is your reasoning? So you are saying that this angles may not be equal, or you can say
Sir, if we take an example of a square and rectangle itself, all the angles are 90 degrees, but it may not be that the sides are the same.
right. So we can just stop this project. Yeah, that's perfect. It was, and we did not realize it. Does everybody see? Yeah, Nandini, Pragdish. I mean, just because those who have also not spoken, I'm just want to know if you guys understand this.
Can you just repeat that?
Yes. So what Aparna Nandini is? Okay. Do you understand what?
Sir, it would be better if you repeated it again.
Yes, yes. So like you see, we have this. So all Aparna is saying that, see, it is very simple. Why are you wasting so much time? Right? It is very simple because you take a square and you take this rectangle. All angles are same. But are they similar? No. I mean, in the sense that is the ratio of the sides same? No, it couldn't be. Okay. Right. So all the angles are same. Like what Satya said, that you just make all the corresponding angles same and then it's fine. Fine. Here all the angles in the sense that this angle is equal to this angle is equal to this angle. That is what we mean. I mean, all the angles are same, that's a different thing. That's also true, but the corresponding angle same is what we are trying to understand. Simple. We were thinking in this complicated way, right? But Aparna is just giving the simple counter example. See, this is this small things, and this discussion you have to have with yourself. Okay, these discussions you have to have with yourself. This self thing, like just sitting and just exploring yourself with your pen and paper is what you have to do to get more and more interaction. Good. So this was very good. Yeah. See, in if somebody thinks more algebraically, you could also say that, look, if this is so all we have is that this is x, let's say, and this is y, okay, and this is z and this is w. Okay? We are just told that x plus y is sort of told, right? This is fixed. Think about it. This is what is given, right? This full thing is given to be some fixed because that is equal for both the things. And then this z and w is also given to be equal, is also given to be fixed. But that does not tell you that x and y is known. Does it tell you if this is given? Like, suppose I told you that this is 60 degrees. And suppose I told you that this is 90 degrees. If x plus y is 60 degrees, does it mean x and y are 30, 30 or 40? It could be any combination, right? So let me explain this more. So this figure is there, but just focus on this other figure. Suppose that this is 60 degrees. Right? Yeah, but it is not 60 degrees. It looks like 90 degrees. So 90 degrees. And let's say that this one is a little like 60. So you forget this one. 60 degrees. So 90 plus 60 is 150. So maybe we can make this 100, more than 100, let's say 120. So how much is the other one? 90, right? Just correct me if it's wrong. Okay. This is given. Now what I'm saying is, from this, see, if this question looks like what is he saying, like all this, there's no number, like confusing, then you tell, or you just do it with numbers. Make numbers quickly and try. No problem. Now the point is I'm trying to make is that if this is given, and then I mean, is this do you know what this is from here? Only from what is given? No. Why? Because you can, again, because all it is given is that this thing and this thing add up to 90. But what those two things separately are is not given. So there could be some other combinations which would give you 90 there, right? That two splitting. So you can make another figure, right? So let us say that in this figure, okay, let us say that in this case is 45, 45, like initially what Satya was saying. Okay, let us just assume. Let us assume that in this case is 45, 45. And then this one you can probably find. What would this two be? Just quickly tell me. This one, 16, 15, right? And then this would be
Yes,
45.
50.
Right? So this is good, nice. But then you can make some other figure, right? Because nobody is stopping you, right, from making. So let's say in this case, yeah, I mean it's just what I'm trying to say is that now you can keep this angle as it is, and you can change this 45 and 15, right? You can you can give the 5 to 45, make it 50, and make this 110. Can't you do that? Why? You can do it, right? You just make this, just see like that 120 is sort of moving a little bit, so that that 120 is remaining the same. And probably it's maybe, I don't know, somebody's finding it, some people may be finding it too easy, but I mean, okay, then we'll do harder versions of this. 50, and then this is 10. You're free to do this. And because you're asked to produce, you're asked to say if this itself, if the initial information itself was enough. And so you produce another figure and say, look, this is not enough. I can produce another figure which satisfies the same initial information. This is 50 and 10, right? But you need to keep you need to keep this 90. That's the deal. That's the deal, right? What is the other deal is that you need to keep this 50 plus whatever to be 90 again, right? That was also the deal, right? So this has to be 40. Fine, I'll make it 40. It's kind of easy, right? It's 50. I've got another figure. Is it okay? Are these two similar? No. Now, I mean, if this is given, you get, oh, no, it's not similar. Certainly not similar. So what do we learn? What I learned, I did not know this before, right? Is that just knowing that the sides, knowing that the angles are the same, that does not tell me that the ratio of the sides should be same. Okay? So the lesson is that we should not just quickly rush to conclusions. I mean, in the sense that we learn this, but you say, right? Anyways, in a sense, what I'm trying to say is that as you increase the number of sides, it seems like there is more degrees of freedom. There's more degrees of freedom. Okay? Right. Now here is a homework. Note it down maybe. And you can just think, if you don't like that, you can just take some ratios. I mean, take some exact numbers and do. Okay, I'm not yeah. If ratio of sides and see if anyone is not following, you have to come, you have to stop me and ask me. Okay, I'll give you guys that responsibility. So I'm not seeing, right? So you have to just, because it will do others also, as my professor also says, it will do others also good, because maybe others are also not asking. But if you come forward and ask, then it's, and it will help me to explain it in a different way, and it will be always a new perspective. Yeah. So if ratio of, so you know what I'm asking, right? I mean, this is just the ask question, will come to your mind yourself. If ratio of sides is given, I don't know, this tab is acting, am I not using it correctly? It's a new, is given. I mean, it is, if ratio of sides is same, so you have two figures, the ratio of the sides is same, and then are the angles same? Corresponding angles. So just just some figure and some other figure, and this side by this side. So you can just write numbers 4 to 9 and 9 and 4.5. Just write numbers and just to see you. Does it imply that the angles are same? So that is the question. So can we define similarity from there? Is my question. Okay, so no, don't, if you know it also, don't answer it. Just think about this. Probably we'll end up doing all this only today. Fine, is it okay? Yeah. Now, does anybody see something interesting here? So maybe just these two examples, right? So you see, I have this 120 degrees, right? And I have this also 120 degrees. And that was a deal that 120 has to remain the same, right? And that 90 also has to remain the same, right? And obviously, I mean, all the angles are remaining the same in both the quadrilaterals, only that they're split in a different way, right? They're split in a different way. So if I so let's say I drew a circle. Okay? So just this thought that is coming, and if I drew a circle, like obviously this circle that I'm drawing using these 3 points, right? This where we have the 90 degree, 120 degree, and 60 degrees. These 3 points I'm just drawing a circle, and no, so the circle is not far from accurate. It will go below that 90 degree. Obviously, when 3 points are given, you can't draw too many circles. You can only draw one circle, right? You know that. Obviously, you may not know the proof, but you kind of know, right? You can only draw one circle. So I mean, this circle has no responsibility of passing through this point. It's not there. It does not have to pass through that point. It might not. Will it pass? Leave it. Maybe if you don't know, fine. Yeah? That is not the main point here. Yeah? The point is that I drew this circle and I have this. Yeah. Now, maybe I should have drawn this in the same picture for you guys to see. It's quite what I'm just trying to say is that it's quite interesting that if you have this thing, right? Yeah. This other triangle. So maybe I'll draw it in the same base. Then you can see what I'm trying to say. I'm just saying this because it seems like an interesting thing. And you can try to prove it for homework. Is that, so just focus on the top part mostly. So maybe back. So this is this thing, and then I made a circle. We don't need the full circle. It's there. I have no sense of how it should be. So pathetic, right? I mean, in the sense that it should have at least some sense of how it will be. Yeah. Okay. And so this is my 120 degrees. So this is the first triangle, okay? And this is 45. And this is 15. Okay. Now you see what I do in this picture, or maybe I'll draw this picture and label it with this first. 50 and then 10. Okay, so this picture. Then how do you get that picture? You would just you would say, I'll take this and I will move this a little bit, right? So that 120 remains the same. Okay, and the angle just reduces by 5 degrees here and hence increases by 5 degrees there for the 10, right? So you move it a little bit. Yeah. And please follow this. If you're not following this, tell me, okay? So what happens is that there is a 5 degree loss, right? So this one is 45. And I'm not going to write that is 15. It is 15, but I'm not going to write that because it's understood. And this one we are going to keep to be 120. That is the whole point, right? So let me not even write 120. It's just understood that they are the same. Yeah, so subject is understood, then we shouldn't overwrite. Otherwise, we lose the picture. Right? First of all, if this point A, let's say ABC are given, so that A is given. So this ABC is a fixed triangle, right? Let's say it's a fixed triangle. Yeah, I mean, let us say it's a fixed triangle. Then can you show that this A prime is unique? That there is only one such way to move A to that A prime so that this angle becomes 45 and that angle hence becomes 50. So what are the rules, right? The rules are that you have this ABC which is given, it's fixed. Now I am to move that A. Okay, well, what is the deal? Is that angle 120, that black angle 120 at A goes to A prime, but that angle should not change. That is the deal. And the second is that 50 should become 45. That's the second. I am saying that with these two conditions, you can only get a unique point A prime. Is that understood?
Yes.
Right? Why is it unique? Meaning that there is no two ways to that point A prime. So even though that I'm not saying that B A prime should be this and A prime C has to be that, I'm not putting those conditions, yet it has to be fixed. And that is simply because if ABC is fixed, then ABC is given, right? Then basically this BC is given. So BC is, let's say, whatever it is, that doesn't matter, but it is a given number 10. Now the point is that if that is 10 and this is 45 and this is 15, that obviously you get a unique triangle, right? You have a unique base and unique angles, 45 and 15, then that A prime has to be a unique point. You get a unique triangle, right? With this base and two angles which are, common from the base. You don't get two different triangles. You just try to, yeah, I mean, if this is given, this angle is given, this angle is given, then I don't have much choice, right? But obviously, you know it as a thing. And this A prime is fixed. There is no two choices for it. My claim is that this A prime will be on the circle. Show A prime is on the same circle. So I'm just trying to say that, look, you don't get similarity by just having angles same, but you do get something, meaning that all these counterexamples sort of you're moving this 120 degree, it goes, you can make some other quadrilateral, but they will all, sort of, so that vertex A is sort of going to move on that circle only. Try to show that A prime is on the circle. It's not, maybe, I don't know, it's easy or not, depends. We'll have to see. So that's the second homework. Okay. I mean, homework in a sense, just think about it. Then we will come back and discuss it, because it's some interesting and also very important cyclic quadrilateral geometry, which is a standard topic even in the school syllabus. It is a standard topic, will be used, but maybe in a more conceptual anyway. So yeah, note is down, and then we'll come back to the, and I'll ask some other questions. So let's see you guys on the other side, and we'll discuss, and in the end we'll end the day with solving this question, initial question. Okay, just join again, just end the meeting.